Okay, guys, I am going to do your homework. I actually started it in a different video and then my mother called, so I had to stop. So I did start. I'm doing 1 through 16 odd, you had even. So the first one was secant squared theta minus 1 times cosine squared theta equals sine squared theta. I recognize that secant squared theta minus 1 is tan squared theta. You should have your list of identities in front of you when you're doing your homework. I then changed tan squared into sine over cosine squared, canceled that out, and was able to get sine squared equals sine squared. The next one, once I wrote it, I realized that sine squared and sine squared, okay, can be factored out. I factored out the sine, and I was left with 1 minus cosine squared. I changed the 1 minus cosine squared to sine squared, and that was sine cubed. And now this is sine cubed theta equals sine cubed theta. Let's look at question number 5. Question number 5, I can't see the book from here, hold on a second, is cotangent squared theta cosecant squared theta minus cotan squared theta, and they want it to be cotan 4 theta. Okay, guys, I hope that these are getting a little familiar to you, that you see that this term and this term both have a cotine, oh my God, I can't speak, cotangent squared. Factor it out. Cotan squared theta. If I pull it out of this term, I'm just left with cosecant squared theta minus 1 equals, this again is going to be an identity. Cosecant squared theta minus 1 is really cotan squared theta times the cotan squared theta is going to give me cotan, I wrote cosine, sorry, cotan 4 theta, which is what I wanted it to be. Let's look at number 7. Number 7. Okay, we have a fraction there, so I have secant theta over sine minus sine over cosine. And I want it to look like cotan of, I think I'm copying 6 and 7. Sorry. Nope, I am cotangent theta. This is number 7. All right. I have fractions. I need to have common denominators. So I'll multiply this whole fraction by cosine over cosine, this whole fraction by sine over sine. I'm not going to change this yet. I'm going to leave it. If you want, I can change it. What is secant? Secant is technically 1 over cosine. So when I multiply cosine times 1 over cosine, I'm literally left with 1. I'm going to make it all one fraction. The denominator is cosine, sine. Again, what happened here? It was really, if you want to think about it, it's cosine times secant. But secant is really 1 over cosine. So they cancel out, and that's how I got that 1. Minus sine times sine is sine squared. Oh my God, for the 100th time, 1 minus sine squared is cosine squared over cosine sine. This cosine cancels with one of them. I'm left with cosine over sine, which is cotangent. Okay. Let's go to number 9. Okay, let's see what it says. It says cosine theta over 1 plus sine theta plus tan theta, and they want this to be secant theta. Okay, well, I think I'm going to have to do common denominators again. Do I want to change this to sine over cosine yet? I think I might wait. I can see that this is going to be a 1 plus sine over 1 plus sine. So my denominator is 1 plus sine. I don't have to multiply this by anything, so it's just cosine. Plus, this becomes tangent times 1 is tangent. And tangent plus that is plus tangent sine. Interesting. Does not help me get to secant. Let's see what I can do here. All right, it's a little uglier, so let's start changing this, okay? This is now cosine plus sine over cosine plus sine over cosine times sine. Okay, so this I can multiply and get sine squared. So now I'm just going to work in the numerator for right now. The denominator is going to stay there. So I'm going to have in my numerator cosine plus sine over cosine plus sine squared over cosine. I want them to all have the same denominator, so I'm going to multiply this by cosine over cosine. So now in my numerator, this is still just my numerator, guys. Cosine plus cosine is cosine squared theta plus sine theta for that one plus sine squared theta. Cosine squared plus sine squared is 1. So now my whole numerator cancels out to be 1 plus sine theta over cosine theta. Don't forget, I still have this denominator I have to bring over 1 plus sine theta. I'm going to take this and divide it by this. So what does that look like? That looks like 1 plus sine theta over cosine theta divided by that is timesing it by the reciprocal, which look what just happened. This and this canceled out. So I'm left with 1 over cosine theta, which is really secant theta, which is what I wanted it to be. Ladies and gentlemen, did you notice that I took up the whole page with number 9? Don't give up on it, okay? 9 is similar to 8, so you might want to watch this before you do your homework. All right, let's go to 11. 11 is, I'm sorry, my book is far away from me. I can't see it, so tiny. 11 is 1 over 1 minus tan square theta plus 1 over 1 minus cotan square theta equals 1. Oh, they want this whole thing to equal 1. Interesting. Okay. So be careful with these two identities, because the identity, guys, okay, I want to write down the identity for you, is really tan square theta equals 1. Yeah, well, should we do minus? All right, let's do it like this. Tan plus 1 equals secant. All right, so when we maneuver this, okay, it's not a 1 minus. Everybody thinks that that just translates to, and it really doesn't. Okay, it's not. It's, remember, tan squared is equal to, I'm sorry, secant squared. Tan is equal to secant minus 1, not 1 minus tan. Okay, so it's a little difficult here. If you wanted to, if we factored out a -1 in this, and I took out a -1, I'd be left with -1 plus tan square theta, which still is not that identity. That identity is tan plus 1. This is tan minus 1. So you have to be careful with something like this. All right. I don't know. I think we just have to do common denominator and multiply them by both. So I would multiply this fraction by this, which I'd get 1 minus cotan squared theta. Multiply this by that, which I'd get plus 1 minus tan squared theta over 1 minus tan. This might not be the easiest way, but I don't really see another way right now. I'm sorry. And that's a problem with these. Sometimes you just have to work them out like this. Let's see, do I have anything here? I have 1 plus 1, so I'm left with 2 minus cotan square theta minus tan square theta. I'm just going to work in the numerator right now and see if I could figure anything out here. Oh, this is going to be a little uglier. So this would be 2 minus, this is cosine squared over sine minus sine squared over cosine. I have a feeling I could have done this an easier way. Yeah, there might be an easier way to do this because I'm getting cosine to the 4th. I don't want to do that. First of all, let me just make sure I copied down the right problem. Yeah, this is it. 1 minus 1 plus. All right, let me think about this for a second. Let's go back. This is not working. And I don't know if you guys remember, but I told you that this could happen. So let's go back to the beginning. 1 over 1 minus tan squared theta plus 1 over 1 minus cotan square theta. If I wrote this as the difference of squares, that's not going to help me. And if I multiply them, if I make this sine over cosine, let's see if I do that. If I make this sine over cosine, so this would be, if this is sine squared theta over cosine squared theta, and I'm going to subtract it from 1, so I'm going to make this both cosine squared over cosine squared. Which, if I reciprocal this, this is going to be cosine squared theta over cosine squared theta minus sine squared theta plus, let's do the same thing here. This is cosine over sine, and this is sine over sine. So it's, flip this, it's going to be sine squared over sine squared minus cosine squared. See, it's the reciprocal because that could equal 1, but this doesn't. If I multiply them now by each other, they're not conjugate pairs. If I FOIL this and I multiply them, first is going to give me cosine squared theta sine squared theta. Outer is going to give me minus cosine to the 4th theta. Inner is minus sine 4th theta. Last is going to give me plus, so that's going to make it 2 there. Wow, this is an interesting problem. Okay, I have to do it again. So let's look at it again. I don't know why I'm not seeing this one, unless, again, am I writing the right thing? All right, guys, I'm going to skip 11. I'm going to come back to it. I'm going to do 13 because I'm a little stumped on that, but I will get it. Don't worry. And this happens. So let's go to 13 minus cotangent theta, cosecant theta plus cotangent theta equals 1. Okay, I have conjugate pairs there, so I'm just going to FOIL those out. It's going to be the first squared, which is cosecant square theta, minus this squared, and that is the identity. That one was an easy one. Cosecant minus cotangent is the actual identity, 1 equals 1. That was no problem. Let's go to 15. Okay, I think 15 is going to, no, 15 is not. 1 over 1 minus sine theta plus 1 over 1 plus sine theta equals 2 secant squared theta. All right, definitely doing common denominator here. I kind of think we did this one in class, to be honest with you. I'm multiplying this fraction by that denominator, this fraction by that denominator. So I'm going to get from my denominator 1 minus sine times 1 plus sine, which is 1 minus sine, we definitely did this in class, squared. When I multiply this times this, I get 1 plus sine. This times this is plus 1 minus sine. This and this cancel out, so I'm left with 1 over, the denominator is cosine squared, and I'm going to flip, 1 plus 1, I'm sorry, is 2. I'm going to flip the cosine to get 2 secant squared theta equals 2 secant squared theta. Oh, sorry, I was off of view. All right, what time do I have on this? 16 minutes. I got to go back to 11, guys. It's 1 minus tan squared, 1 minus cotangent squared, and they want that to equal 1. I don't know why I'm having such a hard time with that one. Why am I not seeing it? All right, I am going to think about that. I'm going to drop another video in a little bit. Okay, so hopefully the ones that I did helped you. So number 11 is similar to 10, but I think 11's harder. Great, I got the hard one. All right, I'll come back and show you number 11. If I don't show you it on a video, I will show you in class tomorrow.